Okay, this lesson today, we're just going to apply what we learnt yesterday, which was the relationship between the diameter, the distance across a circle, and the circumference, the distance all the way around. And what we found was that if you do the circumference divided by diameter, you get a value pi, and pi is. And we're going to use the value 3.14. When we come to use the calculator, we will do it using the pi button. You should find your pi button somewhere. If you've got a normal calculator like the Casio's, you'll probably find the pi button is down here on this bottom row, and it's a shift key. So to get pi, you put a shift and X button on mine. It's the same thing on my Casio as well. When you press equals, it gives you 3.141592654. They're the first few digits of pi, and that's accurate enough to do large distances around the Earth to the nearest meter. I think I made a mistake yesterday that this will allow you to do it to nearest 10 meters if you do 6 significant figures. Okay, so we will come back and use a calculator in a bit to do our calculations. The other formula we need is a rearrangement of this. So we say the circumference is pi times the diameter. We also have another little fact that we know, which is the diameter is also 2 radius. So the circumference is also 2 pi r. Okay, so there are key notes. Sometimes, I've not seen it so often, but sometimes you get told in the exam question to take pi as 3.14. Sometimes they tell you to use 22 over 7 or 3 1/7. These questions are normally mental. They're used for mental questions because you can there's going to be some form of cancellation. You might already have seen the answer to this one now, this first question, just by doing it, and we'll show it as I come through. So I want to know the circumference of this circle, and we use our formula. Circumference is pi times diameter. Put in the numbers we know. Well, I know this is a diameter which is 7, so I don't need to do any conversions for it. So the circumference is pi times 7. And if I type that into my calculator, take it over, shift pi times 7, and we get an accurate answer of 21.99 centimeters. When you're dealing with centimeters, a common expectation is look at the next unit down, which is millimeters, and round to that. So rounding this one, we would round to the 9 rounds that up, which knocks forward onto that one, which is 22.0 centimeters. That's a good guideline for rounding numbers, is look at the next unit down, round to one of those. Still quote at your normal value. Like I said before, if this question comes up in a mental question, you'll probably get told use pi as 22 divided by 7 multiplied by 7. 22 divided by 7 multiplied by 7 is 22 centimeters. That's for a mental question, mental maths. And these are calculator maths, and that's a suitable rounding. So let's whiz through the next one. So next one, I want to do circumference is pi times diameter, but I've not been given the diameter this time. So diameter equals 2 times the radius. So 2 times 4, which is 8 meters. Now I can put that number into my calculator, into my formula, pi times 8. And I put up my calculator, shift X to pull up the pi button, multiply by 8, gives me an answer 25.1 meters. Let's do the same as what I said. 13 because that's the nearest centimeter. You may get told one decimal place, you may get told the nearest figure, but this one is to the nearest centimetre. Okay, so that unit there is actually centimetres. Flip question would be to do, what's the information you can tell me if the circumference is 50 metres. So we start with our formula, C equals pi d. Put our numbers into the formula that we know. We've got 50 equals pi times our diameter. Now pi, although it is it's a letter, it is a number we know. So how do we rearrange this to get d on its own? We divide both sides by pi. We'll take the pi across to the other side. This pi times becomes a divide by pi. Okay, just change the colour on that. I'll leave it. So I'm going to put that into my calculator. 50 divided by pi. And I've got to do shift and exp. And that gives me 15.9. So d equals 15.92 meters. 15.92 meters. 15.915 says round up. Okay. You might get asked to give it as a radius. So we can do diameter is 2 times the radius. So the radius is divide both sides by 2. 15.92 divide by 2. Put the calculator back. Answers there accurately, so I'm going to use the answer button and say divide by 2. And that's 7.96. Notice the 7 rounds that up. So they're fairly simple circle questions. Last thing is the sort of thing that you'll get as an exam question with some sort of circumstances. So the first part of this is a cotton reel used for sewing. Has a diameter of 2.5 centimetres. That's the distance across here. So let's just add that to my diagram. This distance there, 2.5 centimetres. I want to make the thread go around once. So that going around once is the circumference. Back up to the yellow. So this question is actually just asking, what is the circumference of this centre part? C equals pi d, formula that we learnt from yesterday. That is 3.14, or pi. Let's get used to using the pi button, shall we? Pi button multiplied by 2.5. Bring our calculator up. Clear. Shift pi multiplied by 2.5 gives me 7.85. Remembering my little rule, we're talking centimetres at the moment. 7.85 centimetres. This unit would be millimetres, so we'll round to that unit, which is 7.9 centimetres. So each time you run it round the thread round, you've used up 7.9 centimetres. This thread is put on the reel in length of 10 metres. How many turns is this? So it's really asking me is, here's a length, 10 metres. How many 7.9 centimetre lengths would fit in? How many of these lengths are there in 10 metres? First thing to notice, units. I need to change my units so they are the same. I'm in centimetres, so 10 metres, 1 metre is 100 centimetres, so 10 metres is 1,000 centimetres. Or if you're using the fraction method, I want to know what 10 metres is multiplied by conversion of meters to centimeters. 100 centimeters is 1 meter. 100 times 100, 10 times 100 is 1,000 centimeters. So we've now converted this to 1,000 centimeters. And the question really is asking how many of these circumferences fit into 1,000 centimeters. Now I would not use this 7.9, there's a bit of an error there, and with the number of turns that go on, that error can get bigger. So I'm going to use the answer here. I'm going to use the more accurate answer. I definitely wouldn't use 7.9, my previous answer here. Possibly 7.85, more likely 7.853, or sorry, 4 because of that. Or I've got the answer button on the calculator. So the number of turns is 1,000 centimeters divided by 7.9 turns. And if I do that on a calculator, 1,000 divided by my answer, it gives me 127 turns. 127.3. So I'd probably say there's 128 turns needed to make sure I have 10 meters. If I went the other way, I'd possibly be giving slightly less than 10 meters. Just to see the difference with what I was talking about with the error. If I do 1,000 divided by 7.9, we're now saying that there's 127 turns, difference by about 2.5 centimeters. Okay, so these are the sorts of questions you're expected to cover in the next exercise. Okay, guys, that's it.